Hi everyone. In this video, I'm going to explain a very important concept of entire calculus known as greatest integer function. Greatest integer function concept is very, very important in JEE Main as well as JEE Advanced. Whenever greatest integer function involved in a question, that question becomes bit difficult rather than easy. So here, before introducing that greatest integer function, I would like to tell you that what is rounding to integer. Rounding to integer. Rounding to integer means when a number is given, which is not an integer. We would like to round lower than that given number, lower integer than given number, or upper integer than given number. So if you are rounding to lower integer, then we call it as a rounding down. If you are rounding to upper integer, then we call it rounding up. So rounding down, for example, I'll give rounding down. Okay. So I would like to 1.57. Rounding down means what is the integer just less than 1.57. It is rounding down to 1. So if the same, if I take 1.57, then rounding up is nothing but this is 2. So is there any notation for that rounding down and rounding up? Yes, there is a notation. This rounding down is nothing but greatest integral part of x. Right. This is greatest integral part of x. So rounding down, we call it as greatest integer of x. Greatest integer of x, which is less than or equal to x. So we represent x enclosed by square bracket. For example, if we ask what is integral part of 1.57. Integral part of 1.57, we write 1. We are rounding down to the integer. Greatest integer of x, integral part of x is nothing but there are several integers less than x. Among them, you have to choose the greatest one. Least integer of x. Least integer of x is represented by like this. X enclosed by open brackets. So if I ask what is least integer part of 1.7, you have to take the upper integer, which is near to 1.7. Upper integer near to 1.7. The greatest integer, lower integer near to given number. Near to given number. So now I will concentrate on explaining what is the greatest integral part of x or greatest integer function. I'll explain with the more examples. See, I have taken a few numbers on a real line. I would like to explain that what is integral part of a number. Very clear. See, any real number can be put between two consecutive integers, right? Suppose if you take any number between 0 and 1, if you take any number between 0 and 1, let us take 0.6, 0.6. So what is integral part of 0.6? Integral part of 0.6 is nothing but you have to rounding nearest integer down less than the given number. So rounding down is nothing but this is 0. Its value is 0. Why do we call it greatest integer? You see, less than 0.6, there are several integers 0, -1, -2, -3, -4. Among those, 0 is the greatest one. 0 is the greatest one. So here, 0 integral part of 0.6 is equal to 0. Like that. If you give some number, let us say root 3. Root 3. So what is integral part of root 3? Integral part of root 3 equal to, you have to rounding down to the nearest integer. Rounding down to nearest integer. So integral part of root 3 equal to 1. Like if you take minus root 5. Okay. So you have to take that rounding down to nearest integer. Integral part of minus root 5 equal to, we can write -3. And observe that every real number lies between two consecutive integers. Like if you take that minus root 5 lies between -3 and -2. And which integer are we choosing? We are choosing that lower one. We are choosing that lower one. This is the lower one. Right. So the greatest integral part of x now can be fully defined. Right. So every real number lies between two consecutive integers. For integral part of x, we always choose the left integer. Every real number lies between two consecutive integers. That is for x belongs to R. For x belongs to R, there exist n belongs to Z such that okay, these symbols are such that n less than or equal to x less than n plus 1. You take any real number, you give any real number that we can put between two consecutive integers. Now, how do we define integral part of x? How do we define integral part of x? The greatest integer. Now, the greatest integral part of x. Greatest integral part of x. Integral part of x. Okay, denoted by an x enclosed by square brackets. An x enclosed by square brackets, read as integral part of x. Read as integral part of x. Integral part of x. There is another notation for integral part of x, that is known as a floor function or floor of x. Floor of x. It is also represented by like this. Floor of x. It is nothing but floor of x. Floor means we take the value, we take the integer lesser than x, lesser than or equal to x. We take integer lesser than or equal to x. Like you see, integral part of root 3 equal to 1. Integral part of 0.6 equal to 0. And defined as that f of x equal to integral part of x equal to, you take only left integer, that is n. So this is equal to n. where n is an integer, n less than or equal to x less than n plus 1. If you can remember this last sentence, then your all confusions will be out. Integral part of x equal to n, where x lies between n and n plus 1. What is n here? N is an integer. You always try to aim to fit that given real number between two consecutive integers, and you choose the left integer only. And you choose the left integer only. So this is the definition of greatest integral part of x. Now I'll give you an examples. Greatest integral part of x. Remember, you always try to fit the given real number between two consecutive integers. Put in your mind. Okay. One example I'll give you. You see that. For example, integral part of 2.56. This is equal to what to write? You take 2. Because this 2.56 lies between 2 and 3. 2 and 3. So your aim is always choose that left integer. There are several integers less than 2.56. What are the integers less than 2.56? 2, 1, 0, minus 1, minus 3. There are infinite integers less than 2.56. Among those, you have to choose the greatest integer. Among those, the greatest integer is 2. Among those, the greatest integer is 2. That's why it is called greatest integral part of x or greatest integer function. When we define domain and the range, then we call it a, we later on I'll discuss about that. Okay. Similarly, you always try to put that number between two consecutive integers. What is integral part of 3? Anyway, it is an integer. It is an integer. So actually this number is 3 because 3 lies between 3 and 4, less than 4. You always choose the left integer. You always choose left integer. Like that, for example, integral part of minus 3.78. You take this. This is equal to what is the integer less than minus 3.78. No confusion at all. There is no confusion at all. So the integer less than minus 3.78 or minus 4, minus 5, minus 6 and so on. Among those, the greatest one is minus 4. Or this minus 3.78 can be put between two consecutive integers minus 4 and minus 3, and your aim is to choose only this lower integer only. Your all confusions are out. So now whatever number you give, easily you can find out that integral part of that number. So there are some certain numbers which are very important in mathematics. Those are the irrational numbers. See, E is an irrational number. Its approximate value is 2.718. And E square is approximately equal to 7.29. I'm just assuming, okay? 27 into 27. And pi value approximately equal to 3.14. Right. And the pi square value approximately equal to, this is 9.19. I'm assuming, okay? Now, I would like to write that integral part of some irrational numbers. Integral part of some irrational numbers. Well, this integral part of what is E square. Integral part of e square is only you take the integer, that is 7. Because e square value lies between 7 and 8. 7 and 8. For example, integral part of minus pi square. I would like to write integral part of minus pi square. Nothing but integral part of minus 9.19. Remember, you have to choose the integer less than or equal to given number. So here its value is minus 10. Now I will write that greatest integer function definition once again. Once again, okay. Before that, I'll give some more examples like integral part of 7 by 8. Anyway, 7 by 8 lies between 0 and 1, so its integral part is 0. Lies between 0 and 1. Or integral part of minus 13 by 4. Minus 13 by 4. Okay, so its value is minus 4 because minus 13 by 4 lies between minus 4 and minus 3. Okay, I'll take a little break and I'll write that greatest integer function definition. After that, I'll draw the graph of greatest integer function. And also, see here we have given an input and we are expecting the output. So expecting output is very simple. Sometimes we give the output and we ask the range of the input. The range of the input. So here is the definition, exact definition. Of course, before one is also exact definition. This is a more mathematical terminology I have used here. Greatest integer function, we call it like a GIF, or it is also a floor function. We always take integer less than or equal to given number. Integer less than or equal to given number. So let f maps from set of real numbers to set of integers. Set of real numbers to set of integers be a function defined by f of x equal to integral part of x. Okay, how to read it? Integral part of x equal to n. Once again, you keep in your mind that you try to fit the given real number between two consecutive integers. So here x lies between n and n plus 1. You always choose the left integer where n is an integer. Or, so there is another notation that f of x equal to integral part of x. We call it like a floor function. Okay, floor function. There are two kinds of functions. Rounding down is a floor function. Rounding up is the ceiling function. Ceiling nothing but above. Floor means down the value. Okay, so floor function. All right. So generally we confuse with those square brackets. So whenever they use the square brackets and they have to specify that it represents a greatest integer function, right? So like this, represents or denotes greatest integer function, or integral part of x is greatest integer function less than or equal to given real number. Less than or equal to given real number. So this is over. What is the greatest integer function? Now I have given input and we have written that output. But when output is given, what is the input? What is the range of input? For example, you say when output is given and how to find out the input value. when an output is given. For example, integral part of x equal to, you take 0. What is the range of x? What is the range of x? Right? See, here integral part of x equal to n, where x lies between n and n plus 1, n is included. Left one is included, right one is not at all included. So here n value is 0. So I just write 0 less than or equal to x less than 1. Simple. Like that, for example, integral part of x equal to 1 is given. Integral part of x equal to 1 is given. Then we write 1 less than or equal to x less than 2. Simple. For example, integral part of x square equal to 0 is given. Integral part of x square equal to 0 is given. Right? So, which means that x square should lie between 0 and 1, 0 included but not 1. 0 included but not 1. Of course, using that wavy curve method, we can find the range of x. X lies between -1 and 1. -1 and 1. So like that, if you give the input, then we can find the output. And if you give the output, then we can find the input. So if you are able to understand by writing that output and input, then easily you can draw the graph of greatest integer function. So I'll write here several values, you see. So in order to draw the graph of greatest integer function, first we have to list out a few possible outcomes and in inputs. Graph of y is equal to f of x equal to integral part of x, right? Okay, here I am going to write a few values that y is equal to integral part of x equal to. I am taking a few outputs and accordingly I will write the inputs. Well, okay. So suppose the output is 0. What is the input? Input is not a single value. Input is not a single value because integral part of x equal to 0, for many values integral part of x equal to 0, for many values. What are those values? Those values just we have seen there that x lies between 0 and 1. You always try to remember x lies between n to n plus 1. If I give 1 between 1 and 2, whatever output is given, you start the inequality with that integer, Output is always integer. That's why we call it integral part or greatest integer function. If output is 2, then you start with 2 and end with immediate integer 3. Like if I give -1, between -1 and 0, left side equal to will be there, right side strict inequality will be there. And it is -2, between -2 and -1. Well, if you want to draw the graph of integral part of x, you must know that how to draw the line y equal to k. How to draw the line y equal to k. What is the position of y equal to k? So y equal to k line is parallel to x-axis, at the height of mod k units from the origin. I'll draw that graph. After that, I'll draw the graph of integral part of x. So here I'm going to draw the lines parallel to x-axis. Here this red line represents an x-axis. Equation of x-axis is y equal to 0. Any point on x-axis like x comma 0. So y coordinate is 0. If we assume this is 1 unit, then this is the line y equal to 1. So y equal to 1 line parallel to x-axis at a distance of 1 unit, right, above the x-axis. If it is 2, then it represents y equal to 2. So y equal to 2 line is parallel to x-axis. Similarly, if it is minus 1, then we can write this is equal to y minus 1. If it is minus 2, then we can write y equal to minus 2. So with the help of these lines, we can draw the graph of integral part of x. Here you see we have y equal to exactly 0, y equal to 0, and y equal to 1, and y equal to 2 line, and y equal to minus 1 line, and y equal to minus 2 line. Okay, but we have limit that we have to take between y equal to 0 between 0 and 1, y equal to 1 between 1 and 2, y equal to 2 between 2 and 3. I'll draw that graph now. So I would like to draw the graph of y equal to 0 now. Y equal to 0 graph lies on x-axis. So here like this. Okay. Keep the circle at 1 because 1 is not included. 1 is not included, whereas 0 is included. 0 is included. So y equal to 0 lies on x-axis. Now you try to draw y equal to 1 line. Y equal to 1 line at 1 unit height. 1 unit height. Y equal to 1 line parallel to x-axis. Like this. Here you keep the circle because 2 is not included. Here you see. Whereas 1 is included, but 2 is not included. Next, you try to draw y equal to 2 line. Y equal to 2 line. Y equal to 2 line. Like that, you can draw y equal to 4 and y equal to 5, etc. Okay. Now downside. For y equal to minus 1 line, you have to draw at minus 1. Minus 1. Like this. Here not included. Okay. Here it is included. And y equal to minus 2. Y equal to minus 2. Y equal to minus 2. This is included. If you want to draw, you can draw y equal to minus 3. Minus 3. See, it is looking like steps. So that's why some people call it step function, but I don't want to call it as a step function. I just say it is the graph of integral part of x. So this is the graph of y equal to integral part of x. It is a discontinuous function at integers. It is discontinuous at integers. Means the graph is broken at integers. It is discontinuous at integers. Discontinuous at integers. So I hope you understand that how to find out the integral part of some number. You always choose that lower integer. Integral part of x equal to n if x lies between n and n plus 1, where n is included, left one is included, right one is excluded. So in the next video, I'll explain the properties of greatest integer function, and after that, examples.